Hello, in this video we'll be looking at how a rocket propels itself using the rate of change of momentum derived from Newton's second law. So, let me draw a rocket. Okay, so here's a rocket, and at the bottom this here represents the exhaust gases. Now these gases are, the exhaustion of these gases are things that make the rockets go forward due to Newton's third law, which there'll be a force acting that way due to the rate of change of momentum, and that force will produce an equal opposite force acting that way. Okay, so let's have a look at what is the force. What is this force causing the thrust? So you've got force here, which causes a thrust in the rocket here. Okay, now let's have a look at the second law. So the second law says that the force is equal to the rate of change of momentum, d mv dt. And as in, because the velocity is constant, that can be written as velocity times dm dt. And dm dt just means rate of change of mass. Okay, and the velocity there is constant. So we're assuming the velocity coming out of the rocket is constant. So I'm going to put some values to this to make this easier. We're going to say that the velocity of the exhaust gases is equal to 6 times 10 to the 3 meters per second, 6,000 meters per second, and we're going to say that the rate of change of mass, the amount of mass per second coming out, so dm dt, the rate of mass of the rocket coming out per second, is equal to 2.0 times 10 to the 4, so that's 20,000 kilograms per second. So every second 20,000 kilograms of gas will come out there, traveling at 6,000 meters per second. So what we're going to do is we're going to say, okay, well therefore the force, which is equal, produced by change of momentum, which is equal to the thrust, equal opposite, is just equal to the velocity times the flow rate, dm dt. And flow rate in, we'll say flow rate in 1 second, and that is simply equal to 6 times 10 to the 3 times 2 times 10 to the 4, which equals 12 times 10 to the 7, which equals 1.2 times 10 to the 8 newtons. So your field thrust are 1.2 times 10 to the 8 newtons. Okay, now that is the rocket problem. A more sophisticated and difficult, slightly more difficult question is when it applies to a helicopter question and the same idea. So, that was the rocket. Now let's move on to a helicopter. Similar idea. Here's a helicopter, these are the blades. Okay, there's a helicopter, right. And those are the blades. Let's say the blades have got a radius r. Okay, and it's sweeping out a circle. Okay. Now it's producing air that's coming down from the blades. Okay, so that's air coming down from the blades like that. Okay, and again it's producing a force acting down, so there will be force acting down, and there'll be like that. So there must be a thrust which is going to be equal, and opposite, a thrust acting up. Let's draw it equal opposite. Okay, now, what is this thrust? What is this force? So you can imagine there's a flow rate coming down. Okay, so one way to think about this is the fact that, okay, so here we are. Here's the force is equal to the constant velocity of air coming down times dm dt. Now, so let's say that, okay, the velocity is v. So the velocity of the air coming down is equal to v. We have the radius swept out equals r. And let's say the density, we're going to use density this time, density of the air is rho. Okay, so how are we going to use that? So, force equals velocity. Now, rate of flow of mass. Now, what we're going to use now is we're going to use something called, to make this easy for us, to find out what its force is, the 1 second rule. Okay, so what happens in 1 second? Okay, so what is the volume of air that comes down to the helicopter in 1 second? Therefore, we can work out, if we know what the volume is, I'm going to rub this off for now, if we work out the volume, we can work out what the mass is by multiplying by density. So we have, of course, the volume is equal volume in 1 second. In 1 second, okay. So in 1 second, the air will move distance of v. So it'll be distance of v times pi r squared. Okay, so pi r squared being the area times the cylinder of air pushed out. So that is the volume. And we have therefore the mass is equal to volume times density. So the mass is equal to volume. So v pi r squared times rho. So that's the mass in second. And we'll assume that in our from 1 second rule, so F equals B dm dt, so or equal to V times change in mass over change in time. Now, if in 1 second, that'll be delta is just equal to 1. So that's just equal to velocity times the mass in 1 second, which equals the velocity times V, velocity pi r squared rho, which turns out as v squared pi r rho. Okay, and that's the answer.